This is the Illinois Nutrient Loss Reduction Podcast, Episode 32. I'm University of Illinois Extension's Todd Gleason. Are these tools in your toolbox? Soil sampling and variable rate technology. We're joined by Dennis Bowman from University of Illinois Extension to talk a little bit about variable rate technology and its application on the farm. I caught up with Dennis and asked him what it was he's been doing for Extension over the years and how that's incorporated into his work.
I've been in Extension for 39 and a half years. Since the mid-1990s, I've been working on the developing area of precision ag with GPS and how that has been added to our tool set and using yield monitors and variable rate, and then on into the use of drones and aerial imagery in field crop production.
You know, what is VRT, or variable rate technology?
So that is using some of the new technology and computer controls on our fertilizer applicators, our sprayers, our planters, so that they can change the rate of the input that's being applied to the field. And so you tie that with a GPS system and a prescription map, and then through some method you've decided you need to change the inputs for different parts of the field. And so the first place we started pretty much was with fertilizer for phosphorus and potassium. So using soil test information, we created maps of the field as to where the high levels were and the low levels were, and then we could create prescription maps that we could put into our the computers on our controllers on our tractors and implements that would automatically adjust the rate as you moved across the field, using the GPS signal to tell you where you were and what the right rate was in that spot.
Are you conducting, or have you been conducting, research in this area?
Yes. Early on, I worked especially with variable rate nitrogen work, and then also worked with a few other people on phosphorus and potassium projects as well.
How does soil type, maybe topography, impact VRT?
So as we need to come up with a way to make these prescription maps, and so we've got to understand what some of the underlying characteristics of the field are. And so we can use soil type information, the topography of the field, the soil test information to try to figure out where that variability is, and then make the decision about how that may affect what kind of rates we want to put in there. So if it's if there's a lot of variation in soil type in a field, and you've got some really poor soil types that may not respond to high plant populations, we can adjust seeding rates down in those areas of the fields where you don't have as much potential possibly. So we can look at those kind of things, and we will look at, as a base, generally for fertility recommendations, we try to start with a grid sample, the 2.5 acre grids, to get a good idea of what's going on in the field. There's some debate in the industry about using grid samples versus samples that are designed by soil type and topography. My preference is to start with a basic grid sample to try to find areas that are low. Because sometimes as we've progressed in agriculture, our fields have gotten larger, and that means that we've taken farmsteads out of production, out of buildings, and put them back into field space, taken barn lots and incorporated those into fields, combined smaller fields into bigger fields, and that history sometimes brings a legacy with it, with the nutrient availability in those fields. So finding those spots that are kind of man-made or induced is something you can do with a good grid sample. And then as we go farther into the area, we can start looking at the soil types and the topography to try to create zones in the field. So you hear this management zone concept as we're trying to develop variable rate applications. And so that helps us get a more accurate representation of the what's happening in the field, but we need that grid to start things off, and then we can build these zones that'll aggregate the data in the field, and so we can make management recommendations and changes using our variable rate technology to do that. So there's some benefits to doing that.
To this point, we've talked about agronomic types of functions, meaning aimed at profit, relatively speaking. Are there ancillary functions of this that would impact water quality and soil health? And then the follow-up question is, can you actually target it and have a different view of what VRT does?
So we talk with fertility, we talk a lot about the 4 Rs and making sure we've got the right rate in the right place. And so that's a lot of what variable rate does. Picking out those areas where you don't need to be applying a lot of fertilizer because you already have, or it's naturally there, and not putting a full rate on those areas. So doing a more accurate job of applying the nutrients often results in applying less nutrients. Not always, but over time, that's one of our goals, is to not put out excess nutrients that we don't need in certain areas. And so that comes back in the area of nutrient loss.
What are the next things coming down the pipeline in research?
So we're looking at, in addition to varying the rate, to doing a more accurate job of placement. I think that's a lot of what some of the newer research is how we apply that, and where we put those nutrients more in relation to where the plant's going to be. And so how we incorporate some of that placement technology with the variable rate technology is an area that I think folks are going to be looking into.
Any advice for farmers interested in adopting VRT for fertilizer applications?
Well, it's one of the easiest things to do, because most of the times we're actually hiring outside groups that have already invested in the technology to do some of those applications for us. So when in the area of precision farming, it's often the easiest place to get started. Again, having good set of soil tests to start with is probably a good key, and then communicating with your agronomists about what your goals are and what they can do and how they do their analysis, understanding how that analysis and how those maps are going to be made.
That's Dennis Bowman. He's with the University of Illinois Extension and located here on the Urbana-Champaign campus of the U of I. At Southern Illinois University, Assistant Professor of Soil Management and Cropping Systems Amir Sadapur has been doing some VRT research in Carbondale. I asked him to tell me a little bit about what he's been up to.
Here at SIU, my position mainly requires me to conduct research and also to teach. I teach most of the upper level course related to soil at SIU. My research goal is to improve farm profitability and reduce environmental footprints. And with have that in mind, most of my research is mostly related to integrated cropping systems and nutrient management, and how designing better cropping systems and improving nutrient management can impact soil health. I'm very interested in cover crops, their management, how they fit within our cropping systems to improve nutrient cycling and also soil health, without impacting farm economics. And also I'm very interested in precision nutrient management, especially nitrogen management and corn.
Have you used that kind of management or the variable rate technology in some of your integrated cropping systems?
Yeah, so I'm currently collaborating with Dr. Josh McGrath at University of Kentucky on a precision and management project that is funded by Illinois Nutrient Research and Education Council for Illinois sites. And we also have funding coming from Kentucky Corn Grower Association for his part of the funding to do the collaborative project. So what we've seen is that due to the a lot of spatial and temporal variability that exists in the soil, and as we are observing it in our yield map, and due to changes in weather, the nitrogen need of the corn can be different from one year to another or one site to another. So we think that our current nitrogen recommendation, which is MRTN, that is a maximum return to nitrogen, is accurate, but is not precise. That means, for example, if we have 20 fields, on average, MRTN can predict the optimum nitrogen rate right. But if you go to each of those fields, it could be wrong in many of them. So approaches like MRTN are heavily relying on empirical relationship between yield and nitrogen rate. Our goal with our project is to move towards a more mechanistic approach, such as using sensor-based nitrogen management. And currently, Illinois farmers do not have access to regionally specific sensor-based algorithm for variable rate nitrogen management.
Can VRT impact water quality and soil health on that regional wide basis?
Basically, yes. So the goal of variable rate, I'm speaking of nitrogen for this instance, is to get the rate right at every part of the field compared to a flat rate application. So when you go ahead and apply one rate as a flat rate, like what MRTN suggests to us, we are applying nitrogen, for example, higher in some parts of the field and lower in the other parts. So I think there are some trade-offs there. For example, in terms of water quality, if you're applying higher than what the crop can remove, that nitrogen that you're applying compared to the nitrogen that is being removed results in highly positive nitrogen balances. That means we will end up with high residual nitrogen at the end of the growing season, and especially if you're not using cover crops, we have a great potential to lose nitrogen, which would basically decrease water quality. On the other hand, when we are applying nitrogen less than what the crop is needed, that means that we are not maximizing our yield potential, or yield's going to be lower. That means the input that we are adding to the soil is less, for example, the roots or the residue of the corn, and that can impact soil organic matter levels. Excess nitrogen application can also affect soil organic matter. It can accelerate microbial activity and then reduce soil organic matter. I think there are opportunities to reduce reduce the water quality issues and also make sure that the soil organic matter levels are at least staying as they should and not reducing because of low N application rates.
Given all of that, what direction do you think the research will go in the future as it's related to the variable rate technology?
One of the things that we are seeing, and it's very hard to predict, is weather. So weather impacts a lot of our management decisions. If we could integrate predictive models that can predict weather more accurately with our approaches, for example, for nitrogen management, we would be able to do a much better nitrogen management in our farms, and that could allow us to be more profitable and at the same time reduce the environmental footprints.
Wouldn't that require the weather models to be able to predict the size of events as well as the number of inches of rainfall that might come?
That's very true. So now what we are seeing is that the intensity of rainfalls are getting more. We are seeing like maybe a less number of rainfalls, but actually more intensity when they come, and that all are influencing our management decisions and the way we farm. So yeah, I think they should be able to do that to help us do a better management practices.
I'm wondering whether that is on a short-term basis, meaning when do I apply and what does the event look like within the next, 10 or 15 days, or whether it's when do I apply and how much, and what do the events look like over the duration of the season?
So if we know, if we know either both of them actually, if we can have a duration of the growing season and be able to do a better prediction models for those, that would be amazing. That would allow us to be much more efficient in the way we manage nitrogen. But it's at this point it's been a little bit challenging, and that's because just the weather is so hard to predict. And unfortunately, agriculture is so weather dependent.
Do you have any advice on how farmers should adopt VRT into their operations?
I would say that the growers, first of all, they should look at the size of their farm, the scale of their farming, and whether this variable rate technology would provide the benefits they're looking for them. Does it make sense economically for them to adopt it? Another one is to wait for the science to do the job, make sure we have correct and accurate algorithms to help them adopt the management and make sure that they would certainly benefit from that. So I would say it could be different from one farm to another, but overall, I think the benefits are there. Whether it makes sense for them economically, that's the point.
Hey, thank you.
Thank you so much.
Well, Amir Sadapur is an assistant professor and researcher of integrated cropping systems and soil management at SIU in Carbondale, Illinois. Brian Corkill is a farmer from Henry County, Illinois, and has been collecting yield data since the mid-1990s. And he now joins us. Thank you, Brian, for taking the time out of your busy schedule, and welcome to the program today.
Yeah, thank you, Todd. I'm glad to talk to you again. I'll introduce myself. I'm Brian Corkill. I'm a fifth-generation farmer who farms with my dad in southeast Henry County and northeast Stark County. We primarily raise corn and soybeans.
What are the conservation practices you deploy on the farms?
Currently, we no-till soybeans into cover crops. So our cover crops are green when we plant soybeans into them. We do use a vertical tillage tool to seed our cover crops. We have an air seeder on that tool, and we kind of use it like a drill, but that's how we seed our cover crops, and then we will no-till soybeans into that. We also strip till corn. All our corn is strip till, whether it's first year corn, corn on corn, whatever we may do for corn, it's going to be strip till. Some of it also is cover cropped. Typically, we would like to have all of our acres cover crop, but some years it just doesn't work out. So we also have, and we installed a bioreactor on one farm this fall, and we have waterways. And, we try to do as much as we can for conservation practices. So that's kind of what we do for conservation.
Do you use variable rate technology?
Yeah, we do use variable rate technology, and we did start back in the 90s. Obviously, as you had mentioned, that we had already been collecting yield data starting in the mid-90s. We started using variable rate technology for lime, and I think a lot of guys that kind of got started down that path. The lime was the easy button for starting with variable rate technology. But now in our operation, we use variable rate technology in every aspect. So we use it for lime application, fertilizer application in the fall. So we will broadcast fertilizer ahead of soybeans. We'll have our retailer do that. I mentioned that I strip tilled ahead of corn. I have a Kraus strip till bar with a Montag Generation 2 fertilizer system on that. So I can variable rate two separate products through that system, dry fertilizer. We also put on anhydrous in the fall. We don't variable rate the anhydrous in the fall, but I put on a minimal rate, so I put on 100 pounds of N that's anhydrous, so that would be roughly 119 pounds of anhydrous, but actually 100 pounds of N in the fall. And then I'll also in the so in the spring I'll put on a flat rate again with our herbicide program, but then I'll make 1 to 2 passes. We have a Higgy sprayer, we have Y drops, and so I can variable rate that. So we will actually variable rate in during the growing season. We also do variable rate planting as well, so corn and soybeans both. So we're using variable rate in basically every aspect of our farming operation.
And do you use it on every acre of the farm?
Yeah, we use it on every acre. We will, a lot of it, we take into account soil tests, historic yield maps, which that's kind of something that's come out, it's probably been 7 or 8 years ago, but being able to use historic yield maps and using our soil tests, and then we take into account how, drainage and things like that. So we can affect drainage on farms we own, but on farms we rent, we may not be able to really change the drainage. So we do take that into account, bring in weather forecasts and things like that. So that helps us try to, and it's important to get a good weather forecast from a long-term standpoint, so that then we can make decisions to kind of drive our planning prescriptions and things like that. So it seems complicated, but really it isn't. So
clearly you're conservation minded. Did VRT, was it adopted because of the conservation practices, economics, both?
I would say that we adopted VRT at the beginning from a conservation standpoint. I wouldn't say it's necessarily been economic. I think at the end of the day that we probably spend fairly close to the same amount on inputs, as far as fertilizer and lime and things like that. Maybe not lime so much, but more on the fertilizer side. We just redistribute the dollars within the field. So we pick out, the lower producing areas we try to maintain. The higher producing areas will actually put on more fertilizer and try to drive yields higher in the higher producing areas. So we'll typically look at a field and split it up into a 20-60-20 split. So the 20% of the lowest producing areas may get less fertilizer because they don't produce as much. The middle 60% or the average is what I would call them. We kind of keep what we've always been doing. We may tweak it a little bit depending on the field, but kind of what we've always been doing. Well, the middle 60% would be that way, and then the highest yielding 20% will actually try to push fertility and push yields there. So we have actually gotten higher yields that way, and not really spent a whole lot more on dollars for inputs.
On the low 20%, does the maintenance work?
Yeah, so we probably go, a lot of our farms that we've been farming for a long time, we've probably over applied in the past in some of those areas. So we may be a little bit below maintenance on some of those areas, and we're still getting the same yields, especially where we strip till corn. So we'll run. We're probably running 3/4 rate on fertilizer where we strip till, and that has worked, and we've been able to maintain our soil tests because we're applying it in a band in a higher concentration, so the efficiency is a lot better. And then ahead of soybeans, obviously, as I said, we broadcast that, but yeah, we've been able to kind of keep yields at least status quo, if not better, on the lower yielding areas, and improved it on the higher yielding areas because we pushed fertility a little bit more there. So.
Thank you, Brian. Brian Corkill is with BA Farms out of Henry County, Illinois. Andy Wysislow now joins us from Western Illinois, where he works for Waypoint Analytical. Hey, thank you, Andy, for being here. Can you tell me a little bit about yourself and what you do?
Primarily, I handle agronomy for, again, the Midwest and Western U.S. I joke, it's a small area from Ohio to California. And also recently picked up Western Canada to my list of responsibilities, so I get around. But it's kind of varied. I have a pretty varied job. I help our clients with various agronomic issues, either related to their results or just soil fertility in general. We do a lot of training seminars for our clients, and develop training materials for clients that don't need a seminar per se. Support our sales team. I go to a lot of trade shows and conferences and things, obviously, pre and hopefully post-COVID. But another big part of what I do is I also review the quality control for all the samples coming out of the Midwest and West Coast. And I approve those samples, which this past year was about 1 million samples. So Waypoint itself it's the largest agricultural lab network in the country. Probably the world. We've got 7 ag labs across the U.S. And total across all of our labs, we process about 2 million samples annually. So,
do you typically grid or soil sample? And I know we talked earlier in the podcast about this just a little bit, because there is a transition of some sort happening, but I'm not certain which way things will go at this point.
Well, there's a lot of debate about grid or zone. Short answer is it depends. It kind of depends on what your goals are, but it really depends, in my opinion, a lot on what sort of historical data you have to build a zone. So the vast majority of what we do is we process grid samples primarily, usually a 2.5 acre grid. That's the most common, I would say, out there right now. A grid is set up, arbitrarily on a field, and every 2.5 acres we would pull a sample. But it gives kind of the greatest level of precision or resolution, especially when you have no historical data or high resolution historical data to go from. For example, rented ground, there's a lot of leased farmland out there, and in most of those cases, they don't have any sort of historical data. And soils being the highly variable, systems that they are, you want to be able to pick up variability. Now, zone sampling, it's somewhat of an attempt to modify a grid into areas that are similar to each other in a field. It may be a slightly larger area, say maybe 5 to 10 acres. That's pretty variable, but it's developed by somebody that's got a lot of history on a field. So there's a lot of things that can go into it, like obviously several cycles of past soil test data, hopefully that we're on some sort of a grid or higher level of precision. But you're going to take yield maps, topography, soil type. All those should be used to build a zone in an area that's pretty similar in the field. The challenge with zone sampling has been that in a lot of cases, people will build a zone without enough historical data, really just in an attempt to take fewer samples. And that's not the right reason to do it. Good, well-developed zones are great. I mean, it's a great system, but you have to have that historical data in a well-built zone to tell you, where your variability stands. Because if you, go to a larger zone without as many samples, say over 8 or 10 acres, I mean, that's not even really a precision program anymore. So kind of depends on what your goals are.
What percentage of the farmers that you work with use variable rate technology for fertilizer applications?
Well, to note, our primary clientele at Waypoint and really all soil labs is basically ag retail, the co-op, or independent agronomist or consultants. And those are the groups typically that are going to be doing these precision sort of sampling regimes. So we're skewed a little bit from the overall total because the vast majority of what we see are precision, gridded type samples, because it takes a lot of soil samples to do a precision program. But overall, big picture, the numbers are kind of hard to come by. There's not a lot of solid data on it, but I mean, I've heard estimates as much as half of all crop acres aren't sampled at all, period. And then maybe the half that are, I'd say another half of those are probably precision samples. I know in 2013, the USDA estimated that about 1/5 of overall crop acres saw VRT applications, which hypothetically should use some sort of precision soil data. So that's probably increased a little bit. So I'd say about 1/4 of all acres today is a pretty accurate estimation. But so to answer your question, most of what we see is precision or variable rate type applications, because that's what we do.
What do you think the benefits are from utilizing VRT, particularly in relationship to the fertilizer?
Well, the most obvious benefit is that you get a much more accurate picture of your soil's fertility situation, which in turn allows you to more accurately place the fertilizer or lime where it's needed, but also to not place it where it's not needed. Most growers, they know what their typical field average is, but they also know there's spots in the fields that yield better. And they also know there's where the bad spots in the field are. So precision sampling and VRT will allow the grower to more accurately place that fertilizer. And of course, that has all kinds of environmental and economic benefits.
Do you see those economic advantages in adopting VRT?
Well, as I mentioned, the more accurate placement of fertilizer, equates really to more accurate placement of their dollar. So if you're over fertilizing spots that don't need it, then that's basically wasted money. If you under fertilize spots that do need it, that's going to be wasted money in the form of lower yields because there wasn't enough fertility in that spot. One interesting way I think to look at it is that it helps a grower evolve from simply farming for yield to farming for profit. For example, over time, this more precise sampling and VRT application, way of doing things, they might show a grower that there's spots in the field that, they not only yield higher than the rest of the field, but if you add more fertilizer, they might yield even higher still. Likewise, there may be spots in the field that yield so poorly no matter what the soil tests say. Believe it or not, I've seen research out of Iowa that suggests that some fields, there may be spots where the most profitable action might not only be to turn off the fertilizer spreader, but to turn off the planter. There was one particular grower that had a 150-acre field that right in the middle of the field, there were 15 acres he put into CRP because that was the most profitable thing he could do with that those acres. So, having this increased level of precision and data lets you start kind of thinking outside the box of how growers may have normally thought.
Any advice from you for farmers that are interested in adopting VRT?
I would say talk to your retailer, your co-op. If you have an independent consultant or agronomist, talk to them because they're usually the most common routes to get the ball rolling on VRT or precision sampling. Typically, they're going to have the equipment to pull the samples. They're going to have the software that you need to go out and GPS and pull these samples. Plus they're also going to have the ability and the software to put together the application maps, which is obviously important for putting down the VRT fertilizer. If they don't have the ability, there's lots of companies and agronomists out there that do right now. It's a pretty fast growing field. So just whoever you choose, make sure, to get the plug-in for the lab side, make sure that they're using a lab that, puts out good, accurate results because, having quality results is really the basis for this entire thing. So, a good lab with good QC is really important.
Andy Wysislo is with Waypoint Analytical and joined us here on this episode 32 of the Illinois Nutrient Loss Reduction Podcast. Are these tools in your toolbox? Soil sampling and variable rate technology. The program was produced in conjunction with Illinois Extension Watershed Outreach Associates, Jennifer Jones and Rachel Curry. I'm Todd Gleason.